Welcome to Brain Vision.
So what we have is we want, given the surface of the equation, we know that the area is going to be the second, or the two derivatives of 1 plus the square root of 1 plus partial derivative of z with respect to x squared plus partial derivative of z with respect to y squared dA. And that's knowing that f has continuous partial derivatives. So if z is the natural log of x squared plus y squared plus 2, all we need to do is calculate the partial derivative of z with respect to x. That'll give us 2x over x squared plus y squared plus 2. And then similarly, the partial derivative of z with respect to y will be 2y over x squared plus y squared plus 2. Then we take those squared and take their take them squared and add them together with 1 underneath the radical, and what we end up getting is 1 plus 4x squared plus 4y squared over x squared plus y squared plus 2 squared. Now, whenever you see those x squareds and y squareds, we should immediately be thinking, get it into polar coordinates, just to make things a little simpler. So to do that, since we know D is the region inside the circle x squared plus y squared equals 1, we know that's just a circle from 0 to 2 pi with radius of 1. And then we have our r d theta now. And inside the radical, we have 1 plus 4r squared over r squared plus 2 squared. And again, this is dr d theta. So now, since there are no thetas involved, we can just move this d theta over here, giving us 2 pi times whatever this ends up being. And then, in addition to that, we can use our calculator to calculate the rest of this. And what we end up getting when we evaluate the integral with our calculator is that this is equal to 3.5618. And that's our final answer. The only other thing is we want to do it correct to 4 decimal places. So make sure that you keep it at the 4 decimal places.